Okay, here's the Zoom meeting for Physics 231C. We've completed chapters 2 and 3. Now we're working on chapter 4. Chapters 2 and 3 were really just math. But chapter 4 begins to use ideas from physics. And chapter 4 is called Forces and Laws of Motion. So you should read the chapter and take notes. For example, you should have these equations written in your notebook. If the net force on an object is 0, then the object moves with a constant velocity. That's Newton's first law. More generally, Newton's second law says the net force acting on an object is the mass times the acceleration of the object. Newton's third law is really a property of forces. For any force, there have to be two objects. One object exerts the force. The other object experiences the force. Now, for every action, there's an equal but opposite reaction. So in other words, if one object exerts a force on the second object, then the second object exerts a force on the first object. If we call the objects A and B, FBA, the force on B exerted by A, must be negative FAB, the force on object A exerted by object B. And that's called Newton's third law. And we'll see that even more importantly in chapter 6. This produces a conservation of momentum. But we'll see a bunch of examples of this in the homework this week. These are laws of motion published by Isaac Newton in 1687, so 350 years ago. Here's an example of an equation from the chapter, which isn't a fundamental law, it's just a statement about the nature of the force of friction. For simple examples of friction, the frictional force is a constant times the normal force. Normal force means the force perpendicular to the surface. Normal is just one way that mathematicians describe perpendicular. So you should have these equations and many others written in your notebook. You should copy them onto the help sheet that you're going to use during the exam. And we'll see how to use these in the homework today. So let's take a look at an example problem. So here's a problem. This is actually one of the problems in the problem set, which is due Monday. A block is at rest on an inclined plane whose angle can be raised. So the angle is gradually raised from 0 degrees. At a certain angle, the block starts to slide down the incline. It won't slide down the incline when I first raise the angle by a small amount because there's friction. The friction will hold it up. Then it gives you information that at the angle theta I, where the block starts to slide down, then it'll slide with a constant acceleration a distance d1 in a time t1. And the problem is to calculate the coefficient of static friction and the coefficient of kinetic friction. So in all physics problems, you can follow this general method. Step one is draw a picture. So here's a picture. You have this block on an inclined plane with a variable angle theta. And it may be at rest, but if theta is large enough, it'll start accelerating down the inclined plane. And it'll have an acceleration A if theta is large enough. So there's a picture. That's not the picture I need, however. The picture I really need is a picture of the force diagrams. So I'll come back to that in a minute. The second step in the method of solving the problem is to write down the equations which follow from the pictures. And especially for chapter 4, Newton's second law. Then the third step is to apply algebra to these equations and obtain an expression for the answer. For example, coefficient of static friction, mu static, or mu kinetic. And the first step in the solution is to use your calculator to convert the expression into a number. It'll be a number with a unit. You can use your calculator to calculate the number, but you can't use your calculator to calculate the unit. You have to figure out the unit by looking at the equations. All right, so here's a picture. Now I have to start writing down equations. Well, there are two parts to this problem. Theta less than theta 1. I guess that's theta 1. Theta less than theta 1 and theta greater than theta 1, or equal to. For theta less than theta 1, the block is at rest. And this is an example of static friction. So I have to draw a different picture. I have to draw a force diagram. So here's the force diagram. The force diagram shows the object and the forces acting on the object. It doesn't show any velocities. It doesn't show any accelerations. It doesn't show any forces that the object is exerting. All it shows is the forces that are acting on the object. Now, in this case, there's gravity pulling it down towards the center of the Earth. And I know the strength of gravity is the weight, mg. There's a normal force, which is a force perpendicular to the surface. That'll be pushing it up from the surface because the block can't sink down into the surface because there's a normal force pushing it up away from the surface. That's perpendicular. And there will be a frictional force, which will be in the opposite direction from the velocity or the motion. Actually, in static friction, there is no velocity. There isn't any motion either. But, you know, if it were going to move, it would slide down. So the force of friction is in the other direction to cancel that force which is pulling it down. So the direction of the frictional force is always opposite from the direction that the object would move. Now, of course, I could push the block up the incline, and then the block would be moving upward, and the force of friction would be downward. Because friction opposes the motion. For static friction, there is no motion. But it could move down, and the static friction will be in the other direction. Here's the force diagram. From that, I write the equations. And it's just Newton's second law for all the degrees of freedom. In this case, there's only one object, but there are 2 degrees of freedom because there's 2-dimensional motion. So I can consider the direction perpendicular to the surface. The force is N minus mg cosine theta. mg is not perpendicular to the surface, but I can resolve it into a direction perpendicular to the surface and the opposite direction parallel to the surface. Perpendicular to the surface will be downward. This angle will be the same as this angle, so it'll be downward. This is the hypotenuse of a right triangle, so it'll be negative. The hypotenuse is mg times the cosine of the angle, and this angle is the same as this angle. Now for static friction, nothing is moving, so the net force is 0. Now I also have a force going up tangent to the surface. First of all, there's the frictional force, which is directed upward. But there's also the tangential component of the gravitational force. Again, if I think of a little right triangle here, the tangential component is opposite to the angle theta. So that'll be the hypotenuse mg times the sine of theta. But it's in the opposite direction, so it'll be negative. Well, those are 2 equations, but I have one more equation. I have the relation between F and N. And in static friction, the frictional force must be less than the coefficient of static friction and the normal force. So here I have 3 equations that I have to use. And what's the unknown? Oops. What's the unknown? Well, I'm trying to calculate the coefficient of static friction, mu static. So the unknown is mu. So mu is the largest value of F divided by N. That'll be the value of F when theta just barely is just barely high enough that this will start to slide down. So, this always holds with this inequality. But if it's just on the verge of sliding down, then this will be an equality. So mu static will be F divided by N. And this is F by the second equation, and this is N by the first equation. So the answer is the coefficient of static friction is the tangent of theta 1, the angle where it just starts sliding down. So that finishes the first question, part A. Now I have to do the calculation over again for part B. So I go back. I'm going to use the same force diagram, so I don't have to draw that again. I'll still have N minus mg cosine theta is 0 because the block won't slide down perpendicular to the surface. It'll just slide down parallel to the surface. Now F minus mg sine alpha will be not 0, but mass times acceleration, because now the velocity is not constant. The velocity is not 0. There'll be an acceleration, and the force is the mass times the acceleration. Now, if I take A to be the downward acceleration, then F is the upward force, so I have a relative minus sign. So this is Newton's second law now. And in this case, the coefficient of kinetic friction times the normal force is just equal to the frictional force. So I'll have an expression for the coefficient of kinetic friction, which is mg sine theta minus ma, that's F, over mg cosine theta, that's N. Now, I'm not told what A is, but I am told that when theta is just equal to theta 0, then the block will slide a distance d1 in a time t1. So I can figure out the acceleration from the fact that the distance is 1/2 the acceleration times t squared. So I use this to calculate the acceleration. I plug that in here. Then I calculate this to get the answer to the question, mu kinetic. All right, so we did have to use some results from a previous chapter. We have to know how distance is related to acceleration. That's from another chapter. But the main thing is we had to know how to analyze the forces. All right, so let's go on to another problem. That one's a little complicated. Let's go to something which might be a little easier. Well, no, this isn't so much easier. Here we have two objects. So here's the picture. I have two blocks, masses M1 and M2, connected by a cord that goes over a pulley. So these two masses will move together. For example, M2 might move down, and then M1 would move up by the same distance because the cord is not stretching. So if M2 moved down 1 inch, M1 would move up 1 inch. Now, it says M2 is moving downwards, and it accelerates downwards, and the acceleration is given. This angle is given. The coefficient of kinetic friction between M1 and this surface is given, and you're supposed to calculate M1. So in this problem, you have to draw two force diagrams. So here's the force diagram for M2. It's very simple. Gravity is pulling it down. That's a downward force M2G. Tension in the string is pulling it up. That's the force T. Now, for the other mass, there are four forces acting on it. There's the force of gravity, which is pulling it down. The weight is M1G. There's the tension force, which is pulling it up by the cord. That's T. And as long as the pulley is massless, the tension in the cord below the pulley and above the pulley is the same. So this T is the same as this T. There's the normal force, contact of the mass with the surface. Well, the surface is going to push it up because it can't sink down below the surface. So the surface is going to be pushing it up. The normal force is always perpendicular away from the inner part of the surface. We call that N. And its direction is perpendicular to the surface. So in other words, it's theta backward from the vertical direction. And now there's a frictional force. And the question is it up or down? M2 is moving downwards, and it's accelerating downwards. So the mass here is moving upwards. And so this is wrong. The force is opposite to the direction of motion. So the force of friction must be this way. So this is the force of friction. Where this force of friction will be positive. It's retarding the motion upwards of this mass. So here I have two force diagrams. Now I start writing equations. Well, I have to write Newton's second law 2 times. For this mass, Newton's second law says T minus M2G is M2A2. But it's important to understand the signs. It says M2 is accelerating downwards. So A2 will be negative, because that's downwards. T points upwards. Mg points downwards. The acceleration is downwards. So I can write this equation, but I have to be careful to understand the signs. A2 will be negative. And so I probably have a mistake here too. Well, I have a mistake later. Now, what about Newton's second law for this mass? Well, it's two-dimensional, so there'll be 2 equations. There'll be the equation perpendicular to the surface, but there's no acceleration perpendicular to the surface. The mass isn't going to jump up off the surface. It's just going to slide along the surface. So n minus m1g cosine theta, that's the net force perpendicular to the surface, that'll have to be 0. Now, on the other hand, t, which goes up the surface, and I guess this should be plus, so let's see. A is going to go up the surface. So I guess this should be positive. Up the surface. Plus T minus F. Now this has a component down the this has a component, if I look at this little right triangle, it has a component downward, which will be m1g sine theta, but downward. So I guess I have some of these signs wrong. I guess this sign should probably be negative. That'll give me M1A1. And you have to be careful to understand the signs. I'm not sure I've got all these signs right. Now I have some other equations. This is a case of kinetic friction. So the frictional force is mu times the normal force. And mu, the coefficient of friction, is given up here. And furthermore, A1 and A2 are related because if M2 moves down by 1 inch, M1 moves up by 1 inch in the same time. So A1 and A2 have to be equal. Except M2 is moving down, M1 is moving up. So I guess I really should have a negative sign here. So you have to think about these signs carefully. There probably should be a minus sign here. So you have to think carefully about the signs. I'm not sure these signs are correct. But anyway, you see where all of these things come from. I guess it would be the easiest way to do this problem would be to say, I'm going to calculate this A2, and I'm going to calculate this A1. And those will have to be equal. But A2 will have to be upward. Sorry, A2 will have to be positive downward. All right, well, now I have a bunch of equations, but I don't have the answer. The question is, what's M1? Well, if I look at this equation, I can write T is M2G plus M2A, so M2G plus A. And if I look at this equation, I can write that T is equal to M1G sine theta, that's here, M1A, that's here, and F. And F I can write as mu N, but N is M1G cosine theta. So that'll be mu M1G sine theta. So this part comes from this part comes from F. This part comes from M1G. This part comes from M1A. Now you see I have T equals T. So I have this equation equals this equation. The only unknown in this equation is M1. So now I can solve for M1. Everything else is given in the statement of the problem. So I can solve for M1, and that's what goes in the box here, is M1. Well, I didn't get all the signs right here, so you have to be careful. Figure it out yourself very accurately, which are the correct signs. But this is the method. You reduce it down to a number of equations. You combine those equations until you have an equation in which the only unknown is the quantity you're trying to calculate, in this case, M1. The rest is algebra. I mean, the rest is just arithmetic, really. You notice I never picked up my calculator because the first step is to get an expression and then use your calculator to calculate the unknown in the problem. All right, let's try another problem. Oh, I want to emphasize the only way you can do this is by drawing these force diagrams. That's the starting point. Okay. Let's try this problem. This problem is a lot easier. Again, we have two objects moving. Masses M1 and M2 are in contact, sliding across a floor. There's no friction. There's a force acting on M1. They'll both move in the X direction. So this is a lot easier. It's just, it does have two objects. So I'll need two force diagrams. But it only has one dimension of motion, namely X. So we start by drawing two force diagrams. What's the force diagram for M1? Well, here's M1. We want to draw all the forces that are acting on M1. We're not going to draw any accelerations. We're not going to draw any velocities. We're just going to draw forces. So what are the forces that are acting on M1? Well, it's got this force F. Somebody is pushing it. So think of this as you. You're standing here and you're pushing M1. And you're exerting a force F. And that's given. Here's F, points to the right. Then there's another force acting on M1 because M1 and M2 are in contact. So whenever objects are in contact, there's a contact force. M1 pushes M2 and M2 pushes M1. That's the way forces work. For every force, there's an equal but opposite force. For every action, there's an equal but opposite action. So if M1 exerts a force on M2, then M2 exerts a force on M1. And by Newton's third law, those forces have the same strength, but in opposite directions. So the force, the contact force on M1 will be directed that way. You know, a contact force always points away from the object which is exerting the force. So M1 is pushing M2 to the right. M2 is pushing M1 to the left. So that's F12. And those are the only forces acting on mass M1. Well, there's a force of gravity pulling it down, but that's in the other direction. All I really care about is the X direction. So sure, there's gravity pulling it down. There's a contact force pushing it up, but I don't care about those because those are not in the X direction. If there's no friction here, the contact force will just exactly balance the force of gravity. So that I don't have to care about. Now, what about M2? Well, M1 is pushing on M2. So there's a force to the right acting on M2, and that's the only force acting on M2, at least ignoring vertical forces, which I don't care about. I only care about how it's moving horizontally across the floor. Now I could call this force F21 because it's the force acting on 2, which comes from block number 1. So that's F21. This force will be F12. That's the force acting on block 1, exerted by block 2. So there are the force diagrams. Now I write down equations, and it's easy to see what equations to write. It's just Newton's second law. Newton's second law says the net force is the mass times the acceleration. So let's consider the first block. The mass is m1, the acceleration is a1, the force is F to the right, F12 to the left. So let's just say F12 acts in this direction, F12 will be negative. F will be positive, because the sign tells you the direction of the force. So M1A1 will be F plus F12. But just remember, F12 is a negative number. What about Newton's second law for this block? M2A2 will be F21. Now, what about okay, so I have two equations, but I have numerous unknowns. The unknowns are F12, F21, A1, and A2. M1 and M2 those are given. F, that's given. What's not given is A1, A2, F12, F21. So I have to have some more equations besides these. One thing I know is that A1 is equal to A2, because these two blocks remain in contact. They're just going to move across the floor, always in contact. So if M2 moves an inch, M1 moves an inch. So they have the same displacement, they have the same velocity, they have the same acceleration. So A1 is equal to A2. Might as well just call that A. And then I have Newton's third law. F12 is negative F21. F21 is going to be positive, F12 is going to be negative. Now, what's the unknown? What are we supposed to calculate here? Evaluate the strength of the force exerted by the mass M2. Well, the force exerted by M2 is F12. That'll be a force, that'll be a negative number, but I want the strength of the force. So I want the absolute value of F12. F12 will turn out to be negative, but I want the strength. So I take the absolute value. That'll give me the strength of the force. So that's the first step, draw a picture. That's the second step, write down the equations. Now, the third step is to figure out an expression for F12. So I have to do that up here. I say M1A is F minus F21. I'm going to call A1 and A2, I'm going to call them both A. F12 is minus F21. So I have M1A is F minus F21. And this equation, M2A is F21. So I can solve both of these equations for A and set those equal. So A is equal to, on the one hand, F minus F21 over M1. That's from this equation. And on the other hand, F21 divided by M2. That's from this equation. So now you see I have an equation where the only unknown is F21. So I can solve this equation for F21. That'll be equal to the magnitude of F12 by Newton's third law. There is another way to understand this problem, and that is to consider M1 and M2 to be one object with a mass M1 plus M2. So I could just say M1 plus M2A is equal to F, because the only force external to the system is the force F. So the force F is acting on the mass m1 plus m2. There'll be an acceleration F divided by m1 plus m2. And you see that's a property of these equations, because if I add the left-hand sides, I get m1 plus m2a. If I add the right-hand sides, I get F minus F21 plus F21. That's just F. So this is another way to look at this problem, but it won't solve for the question because that doesn't have anything to do with F12 or F21. They both dropped out. So I need to look at it this way to get an equation where by algebra I can solve for F21. And that's what goes in this box. Actually, what goes in this box is the magnitude of F12. That is to say, the absolute value, the strength. Force is a vector. The direction tells you the direction that the force is pushing or pulling an object. The magnitude of the vector is the strength of the force. By Newton's third law, the strength of the force F12 is just equal to the force F21, which I can solve here. All right, so let's see if there are any questions. On the chat box, I don't see any questions. Anybody want to mute your microphone and just ask a question? Or type a question into the chat box? Okay, then let's go to another problem. Here's a problem from the assignment. You have two masses are connected by a string, and the string goes over a pulley. We did a problem similar to this a minute ago, but here, mass M1 is on a horizontal surface. So M2 will either go down or up. M1 will either go to the right or to the left. But if M2 goes down, so let's assume that M2 goes down, then M1 will go to the right. And the two accelerations will be equal. Because if M2 goes down 1 inch, M1 will go to the right 1 inch. Now you know the masses, and that's all you know. All you know are the two masses. M1 is 4, M2 is 1. That's all that's given. You want to calculate the tension in the string. So this string will have a tension T on both sides of the pulley if the pulley is very light. If the pulley is very light, then the tension going over the pulley will not change. It'll be just as if the pulley weren't there as far as the tension in the string is concerned. All right, so how am I going to do this problem? Well, I have to start by drawing a picture. Well, I already have a picture, but that picture is no good. I have to draw two force diagrams because they're two moving objects. And I have to write the two equations, which are really the same equation, Newton's second law, but applied to the two different masses. So it's once you've got the force diagram, it's very easy to figure out the equation, because the equation just says the net force is equal to the mass times the acceleration for each of the moving objects. So you have one of these equations for M1, and you have one of these equations for M2. It doesn't say there's any friction. So we'll have to assume there's no friction here. Now, draw the pictures and then figure out the equations. But it's pretty easy to do it in your head. M1 will be pulled over to the right by T, and that'll be the only force. So M1A will be T. M2 will be pulled down by gravity and pulled up by the tension. A string tension always pulls in the direction of the string. You can't push something with a string. You can only pull it. So the string will be pulling it up. So M2A will be, taking A to be downward, will be the force of gravity. That's just a weight, M2G minus T. So here I have two equations with two unknowns. What are the unknowns? A and T. I know M1 and M2, they're given, and G is 9.81. So I have two equations for two unknowns. I'm supposed to calculate T. So I have to use my skills in algebra to figure out T from these two equations. Oh, actually, there are two answers. So I'm supposed to calculate both the acceleration A, that goes in the upper box, and the tension T, that goes in the lower box. But they come from these two equations with two unknowns. So, if I add these two equations, on the left-hand side, I'll have M1 plus M2A. On the right-hand side, I'll have T plus M2G minus T. Well, the T and the minus T will cancel. So I'll just have M2G. So M1 plus M2A is M2G. So A is M2 over M1 plus M2G. M1 is 4, M2 is 1. So A will be 4 divided by 5, G. So what goes in here is 4 divided by 5 times the acceleration due to gravity. That's roughly 8. That's the number, meters per second squared. The answer is always going to be a number with a unit. The number involves arithmetic. The unit involves, you have to figure out what's the correct unit. Well, for acceleration, it'll be meter per second squared. And now what about T? Well, T is M1A. So I just take this answer, multiply by M1. M1 is 1. So T will also be 8. But it'll have a different unit. So T will be 8. M1 times 8. M1 is 1. Kilogram meters per second squared. So that'll be newtons. You have to calculate a number with a unit. Number you get by arithmetic. The unit you get by looking at the equations. Let's see. Someone asked a question on the chat. What is the info in brackets just above the answer boxes? Well, it gives you the value of M1, 4 times M2, and the value of M2. M2 is 1 kilogram. So this information tells you that M2, this one is 1 kilogram. The one it's pulling, M1, is 4 times that, so it's 4 kilograms. Now it says, below that it says, what does it say here? Calculate the acceleration and the string tension force. These, LONCAP is doing something funny here. I don't know what it's doing here. But anyway, you can sort of just ignore that and you can see. Apparently it's saying, evaluate the acceleration and the string tension force. Okay. No, right below that, it's like code. I think you must be referring to these. Just look at this, and I don't think it'll say that on the screen. It won't look like that on the screen. It looks like that because I converted the screen to print it on paper. It's got some weird it's got some weird thing when you print it on paper. When I plug my A value into T equals M1A, I do not get the correct T value. No. When I plug my A value into T equals M1A, I do not get the correct T value. Well, then send a message to the discussion board. Because if I look at these two equations, you get the A value is G M2 over M1 plus M2. And now the T value should be M1A. So if you're not getting the right value, then it sounds like you need to send a question to the discussion board. Can we please do one whole problem? Well, this pretty much is one whole problem. These are the equations you need. You have to solve this equation for A. No, you add these two equations so that you cancel the T's, and that tells you how to solve for A. Then you use this equation to calculate T. Okay. I think this would be the complete answer for these numbers. Now, your numbers may be different. This is for 1 kilogram and 4 kilograms. Your numbers might be different. The way non-kappa works is it gives each student different numbers. All right, so let's see if we could do one more. Actually, these are sort of complicated, so let's do several more. Well, it's getting on towards 5 o'clock, so we should finish pretty soon. Let's try. I got a few more problems here I can look at. Let's try this one. This one, you have a block on a frictional surface. It's pulled at an angle. So we draw a picture. This picture isn't good enough, so we draw a new picture. We say we have to draw a force diagram. So we take the block and we draw all the forces acting on the block. And it has to be in 2 dimensions because the force is not horizontal. So we have the force F. Its magnitude is given, 12.4 newtons. Its direction is given, 23 degrees. So that's the force vector defined here. There's friction. So we have to know the coefficient of friction. That's given here. And we know the mass of the block, 5 kilograms. And you want to calculate the speed 5 seconds after it starts moving. Well, we know the equation for speed. Speed is acceleration times time. Time is 5 seconds. So if we calculate the acceleration, we'll immediately know the speed. We can calculate the speed in one step. And what's the acceleration? Well, it's the force divided by the mass. Now, of course, force is a vector. But this mass is going to move horizontally. It's not going to just suddenly jump up off the floor. It's being pulled in some direction, but it's just going to slide along the floor. So really all I really need is the acceleration in the x direction. The acceleration in the y direction will just be 0. All right, so here's the force diagram. There's gravity pulling it down. There's a normal force pushing it up. There's a force of friction opposite to the direction of motion. Obviously, if I pull it with this force vector, it'll go to the right. So the frictional force will be to the left. And then there's the external force F, which is at an angle. So now I have the vertical force is N minus mg plus F sine of theta. I want the vertical component. This is the hypotenuse, and vertical is opposite to the angle theta. So N plus F sine theta minus mg is 0. That's 0 because AY is 0. The block is just going to slide along the surface. Now I have the force in the x direction. Well, this force projected onto the direction of the surface is F cosine theta. And this force is negative F. Well, if I take this I really should say is negative the magnitude of F. If I take into account the direction of F, F would be a negative number because it's in the minus x direction. But I can take this to label the magnitude of the force. And the force is the mass times the acceleration. That'll be the acceleration in the x direction. Now I also have that F, or I really should say the magnitude of F, is mu n. I need to know A, so I can multiply A times 5 seconds to get the final velocity or the final speed. So how am I going to solve for A? Well, A is F cosine theta. I know what that is. Minus F, that's minus mu n. N is F sine theta minus mg. So I can plug in here for F mu n because I know what n is from the earlier equation. So I'm really combining two equations with two unknowns. And then I'll end up with one equation where the only unknown is A, which is what I need to plug in up here to get the distance. I missed a question on the meeting chat. What happens if you use the other equation to solve for t? Well, you should get the same t in both cases because they're supposed to both, it's simultaneous equations. They're both supposed to be true. All right, let's see what we're down to. Let's see. Done all of these. Here's another one. Here's another one. Here's another one. Actually, I have quite a few. This one, well, this one is similar to the one I did before, only now I include friction here. So here's the force equation for M2. So M2A will be M2G minus T. That's assuming that it's going down. If it's going down, then M1 is going this way. Now I need a force diagram for M1. Well, it'll be similar to the force diagram I had on the other problem, only now there'll be an addition of frictional force. So I'll have M1A, that's this one, is T, pulled by T, and then the frictional force will be minus mu N. And N I can get from M1G has to be equal to N. You know, gravity's pulling it down with a force M1G. It's pushed up by the surface with a surface M. So N will just be M1A. Sorry, M1G. So I have this equation, I have this equation, I have the formula for N. So then I have multiple equations. So I use algebra. And I calculate what's the acceleration of M1. So that's a 1. That assumed that M1 was moving to the right. But suppose I started this whole thing by pushing M1 to the left. So M1 is initially moving to the left. Well, all the forces will be the same except friction. Now the frictional force will be in the opposite direction. So the frictional force will be, instead of minus mu N, it'll be plus mu N because it's to the left. So I have to do the problem again. I have to do the problem all over again, where I take the frictional force to be to the right, because I start the whole thing by pushing this mass to the left. It'll go to the left for a while, then it'll slow down and go back to the right. But, you know, I'm asking about what about when it's moving to the left? So this is actually two problems that you have to do separately. So this will be A1, this will be A1 prime or something. This will be a different A1. You have to think about the directions of the acceleration. A2 is in the negative J direction. If I take Y to be vertically upward, A1 is in the X direction, in the I hat direction. All right, so that's similar to a problem we did a minute ago. Again, the only way you can do it is by drawing the various force diagrams. Two force diagrams, one of which is two-dimensional. So you need a two-dimensional force diagram for this mass. You only need a one-dimensional force diagram for this mass because it's just going to go up and down. Car slides at a constant speed down an icy road. The slope is theta. What's the coefficient of friction that'll cause it to move with a constant speed? Well, I'm sort of running out of time. It's already 5 o'clock. So as soon as you see constant speed, you immediately say the net force is 0. Because that's Newton's first law of motion. If the speed is constant, then the force is 0. So as soon as you see a car slides at constant speed, that means the net force is going to be 0. And now you have to figure out what are the forces. Well, there's a force of gravity. That's always downward. There's a normal force. That's always perpendicular to the surface. And there's a frictional force. That'll be up the hill. And now you have to write down the equations. N, if I think of the perpendicular to the surface, there's N upward and mg cosine theta downwards. And those have to add to 0 because the car is moving at a constant speed. So I have N minus mg cosine theta is 0. And now perpendicular or tangent to the surface, I have mg sine theta. and minus f in the other direction. Or I can write it this way. F minus mg sine theta has to be 0. 0 because the net force is 0. That's what I immediately know when I see constant speed. So now I have, two equations with two unknowns. I also know that F is mu n, and mu is the unknown. Find the coefficient of friction. So that's mu. So these two equations don't involve mu, but I know F is mu n. So mu is just F over n. It's mg sine theta over mg cosine theta. It's just tangent theta. If the car is moving with a constant speed. Here's the Atwood machine. You've got that assigned as a homework problem. Again, you have to draw two force diagrams, one for each mass, and write two equations. F net equals ma for mass 1, and F net equals ma for mass 2. Here's a problem where I'm pulling a box at an angle. Well, we did the same problem a minute ago. That's just pulling a mass with a force at some angle. So that's just like the problem we did a minute ago. Here's the force diagram for the forces acting on the mass, on the block. Only here it says the crate will move at constant velocity. So I'm pulling it in just the right way so that the crate will move at constant velocity. That is to say, so that the net force on the crate is 0. There are 4 forces acting on the crate, and the net force is 0. So the sum of these 4 vectors is 0. Here's the x component of the force. Well, this is actually the y component of the force. It's n plus t sine theta minus mg. So that's the y component of the force. And here's the x component of the force. T cosine theta minus f. And the net force is 0, so those two components are both 0. Again, f is mu n. So you can calculate, what are you supposed to calculate? Determine t. Okay, so I have two equations with various unknowns. The unknowns are t and I guess n. Coefficient of friction is given here. So the unknowns are t and n. But anyway, you want to solve for t. That's what goes in the box. All right, so we're already 10 minutes after 5, so we should be finishing. Let me ask if there are any last-minute questions. Here's a question on the chat. I have not been able to open my practice test. I have not been able to open my practice test. Is the actual test all multiple choice? Yes, the actual test is all multiple choice. Is anybody else unable to look at the practice test? You should be able to see the practice test. If you're not able to look at your practice test, try log out of Lon Kappa. And that means don't just close the window, but actually log out from Lon Kappa. there's a little button on the top right of the Law on Campus screen that says log out. Hit that button so that you're actually logged out. Then log back in again. You have to log in with your net ID and password and see if you can then see it. But don't just close the window and open it again. That doesn't log you out. But I think you should be able to see the practice test. Anybody else who can't see the practice test? Okay, so try that. Send Dr. Musolf an email if you can't do it. But I didn't have any trouble looking at the practice test, so I think it'll be all right. And yeah, don't forget this homework assignment is due Monday night. The exam is Tuesday night. So now I'll stop the recording.